This is week 10, Introductory Activity, Linear Equations. If you drive 216 miles and use 9 gallons of gas, what is your rate? The rate is going to be in terms of miles per gallon. In this case, we have 216 miles and 9 gallons, and you can divide that out, and you end up with 24. I can take it here and divide it. That's number 1. Find the slope of the line that goes through the points 8, 13, and 3, 5. So with this problem, there are certain things you have to do first. The first thing you want to do, write out your formula. The second thing you want to do, assign values to the variables. So x1 is 8, y1 is 13, x2 is 3, y2 is 5. The third thing you want to do is plug in. And then the fourth thing you want to do is simplify it to get your answer. So I wrote up my formula. Here, I assigned values to the variables here, x1, y1. Then I replaced them in the slope formula here. Then I did my computation, 5 minus 13. 5 minus a negative 13. Is going to be a negative 8. Well, it's going to be a negative 8 here. And 3 minus 8 is going to be a negative 5. So we end up with a positive 8 over 5. Okay. Next one is question 3. Find the slope of those 2 points on the line. Find the slope of the line. So I wrote up my slope formula here. Okay, and identified 2 points that I wanted to use here. And I assigned values to my variables in the formula here. Then the third thing you want to do is to plug into the formula here. Negative 8 minus a negative 8 is going to be the same thing as negative 8 plus a positive 8, which is 0. And here we have 2 minus a negative 2, so it'll be 2 plus 2. And in this case here, we end up with 4. And 0 over 4 is 0. 0 divided by anything is 0. Next one here. The company discovers that to produce x equal to 620 new electronic parts, it would cost Y equal to $44,000. To produce 610 new electronic parts, it would cost $43,000. Compute the slope of the cost and choose the most accurate statement of the following. So the first thing I did here, I got the slope formula. Second thing here, assign values to your variables. X1 is 620, Y1 is 44,000, X2 is 610, Y2 is 43,000. Then you plug in. When you plug in, you end up with a positive slope of 65. And since it's positive, it's increasing. And you can say costs are increasing at a rate of $65 per item. That was number 4. On a bicycle, question 5. Stephanie rides for 4 hours and is 26 miles from her house. After riding 10 hours, she is 62 miles away. What is her rate in terms of miles per hour? How far can she ride in 5 hours? How far is Stephanie riding for 15 hours? Okay. So for this first one here, the first thing I do is I write out my slope formula. Do you want the rate of change? So that this will be the first thing you do. Second thing you do is in terms of miles per hour. The second thing you do is you assign values to the variables that are in the formula here. X1, Y1, X2, Y2. Then the third thing you do is you plug into the formula. And the fourth thing you do is you simplify. In this case, you end up with 6 miles per hour. So the first one there. Second one, how far can she ride in 30 miles? What we need to do here is create a model in terms of y equal to mx plus b. So to create a model, we know what m is. We need to find what b is to find the intercept here for b. So I use the formula again. I take one of the points, 4 and 26, and I plug in to solve for b. And I solve for b. 26 minus 24 is 2. So I have a model here. I use this model for the next two answers. So in 5 hours, we can plug in for x. In 5 hours, the person will go 32 miles. Okay. In 15 hours, we can plug in. The person will go 92 miles. And that's how you got that one there. Okay, and that was question number 5. Question 6. State the run, the rise, and the slope of the line above. This is a line here, and there's our rise. It's going to be the change going up or down. And the rise in this case is a -3, and the run is the run over the change in x. In that case, it's 15. So my slope is going to be rise over run, which is a -30 over 15. Okay. So my run is 15. My rise is a -3. My rise is a -3. And my slope is a -1/5. Number 7. Which of the following rates are equivalent to the rate 7 pounds in 2 months? So I took the rate as it was given and just rewrote it. See which ones I could rewrite in terms of 7 over 2. So the first one here is 3.5 pounds per month. I just multiplied it by 2 and I end up with 7 over 2 here. So that one's the same. So the first one is the same. And I took the next one here. I have 1 pound per 2/7 of a month, so I have 1 pound per 2/7 of the month. Okay. So then I multiplied it by 1, 7 over 7, and I end up with 7's cancel there. End up with 7 over 2, and that was the same. Then I have 28 pounds for 8 months. Okay. And I took each one of these and divided it by 4. And I end up with the same thing there, 7 pounds for 2 months. So that one's the same. This one here is 7 over 7/2 over 1. Okay. I multiply the numerator and denominator by 2. So I multiply that by 2 and that by 2. And I end up with the same thing. Next one, last one here, I have 42 pounds per 1 year. Per year, well, since it's in months, I rewrote that as 12 months. And then I still have 42 pounds for 12 months. So I divided both by 6. End up with 7 pounds every 2 months. So they're all the same there. Number 8. Which of the following could represent a linear function? So if you look at the change here, if it's going to be a linear change, the rate of change is going to be the same. No matter which points you pick. Okay. So you just take any one of these ordered pairs and divide it out. You see that you get different slopes for the first one here. The next one here, you can take any one of these 2 pairs and you'll see that you get the same slope. So for the first one there, we define the slopes. We get 5, do the slope again here is 25, so it couldn't be a linear function. You do this one here, take the first 2 points, you get -3, then you choose another 2 points, you get a -3, you know that one is linear. Then you do this next one here. The first 2 points you choose, you get a slope that's 3. You choose 2 more points, you get a slope that's 3, so that one's linear. So you're using the slope formula here to find out which ones are. And this one here, you take the first 2 points and find the slope. It's 3, then you take the next 2 points and find it's 3. So that one could be linear. So that's what you end up doing there. And then you list they give you the ones that are linear. Number 9 is the function h of x equal to 10x squared, a linear function. No, it's not, because the exponent here in the x term is not equal to 1. So what that means is that particular the 2 values of x, they can give me the same y. So it couldn't be a curve. It couldn't be a straight line. This has to be a curve of some type. And this one here gives a slope and the y-intercept of the line. Y plus 3 plus 10x equals 0. So I took it here and I rewrote it and solved it for y. So when I solved it for y, so I subtracted 3 from both sides. Okay, then I subtracted 10x from both sides, so I have y is equal to 10x minus 3. Okay. Then I wrote y equal to mx plus b underneath it, so I could identify what my slope is. My slope is a -10. The y-intercept is at a -3. Number 11. Given below are descriptions of 2 lines. Line 1 goes to these 2 points at -4,6 and -8,9. Line 2 goes to 0,7 and 8,1. So they want you to find the slopes of these 2 points here. And I've already gone over how to find the slope. In this case, the slope is a -3/4. And then for line 2, find the slope. In this case, it's a -3/4. What does that mean? Parallel lines have the same slope, where the slope of the first line is equal to the slope of the second line. And that is what we have here. Line 1 is parallel to line 2, and that's all they ask you to do. So you end up finding the slope of those 2 points and comparing them. Number 12. Determine the slope and y-intercept of the linear function in the table. So they tell us it's a linear function in the beginning. So we expect to find the same slope for regardless of the points. So first thing I end up doing is I have to find the slope. So I write out my slope formula. The second thing I do is I assign values to my variables in the formula. The third thing I do is I plug in the formula. The fourth thing I do is I do my computation. Okay. So I have y2 minus y1 and x2 minus x1. So my slope is going to be 12 over 2, and 12 divided by 2 is 6. That is my slope. Then I have to find the y-intercept. So over here, I use this formula to find my y-intercept. Alright, so I take one of the points, I chose 1, 9, and I plug it in for my x and y. And I simplify it and solve for b. In this case here, my b is equal to, so I subtract 6 on both sides, and end up with b is equal to 3. So my y-intercept is equal to 3. B is equal to 3. Here the y-intercept is 3. And that's it for that particular problem. That was number 12. Give the slope and the y-intercept of the line. They give us the equation. So what I do is I solve it for y. Okay. So I subtract x over 6 on both sides. I put it in the form of y equal to mx plus b. So I have y is equal to a negative x over 6 plus 1. You can see what your m is. My slope is a negative 1/6. And my y-intercept b is equal to 1. You see that there? And that was number 13. Find the slope of the line in the 5 graphs below. I'll give you answers. There's reduced fractions. So I've already covered how to find the slope for both of these here. You're given 2 points. In this particular case, it's a vertical line. So the slope of a vertical line, it is undefined, and so it does not exist for that first one. Okay, and then you go ahead and use your slope formula and find the slopes for these 2 points. So I found the 2 points there, and you find the slope of these points. I've already gone over how to find the slope of the points. And that is the end of that.